Aerodynamics Laboratory was built at the beginning of the 1960s outside of Nový Knín at the site of a former gold mine. The abandoned mine galleries from Algonquian gold-bearing slate and its high rock cover make up an airtight vacuum storage with a total volume of approximately 6,500 meters cubed. It is used to drive intermittent high-speed wind tunnels. 3 water ring vacuum pumps with a total input of 165 kilowatts are capable of evacuating the space to a pressure of 1/10 the normal atmospheric pressure. The laboratory was gradually equipped with several high-speed wind tunnels connected to the vacuum storage. The atmospheric air is drawn through a silica gel dryer and a set of filters. The flow of air is controlled by quick closing valves with a shutting time of less than half a second. Thanks to the difference in pressures between the environment and the evacuated galleries, speeds of up to twice the speed of sound can be achieved in the wind tunnels. The laboratory in Nový Knín primarily investigates the high-speed flow of viscous and compressible fluids in closed channels, such as flows in nozzles, diffusers, valves, ejectors, and various turbomachinery elements, for example, cascades of radial and axial turbines and compressors. The laboratory also investigates the boundary layer problems and aeroelasticity, which studies the mutual interference of oscillating bodies and flowing air. The largest wind tunnel is used for aerodynamic research of two-dimensional turbine and compressor cascades for speeds of up to Mach 2, even in the difficult-to-measure region around Mach 1. The wind tunnel is equipped with a unique Mach-Zehnder interferometer for quantitative optical measurements and flow visualization, thanks to which the laboratory was the first to study the development of transonic flow in blade cascades, as well as the behavior of turbine cascades at extreme inlet angles. Altogether, more than 100 transonic and supersonic cascades of various types were measured, including the blading of the last stage of the 1,000 megawatt steam turbine for the Temelín nuclear power plant. Based on these measurements, a significant decrease of the loss coefficient was achieved. In 1990, a wind tunnel with a test section of 1.5 by 1.5 by 25 meters was designed and built to simulate the atmospheric boundary layer. This tunnel has its own driving fan, making it possible to research flows over landscape or urban development models. For example, a possible accidental chlorine leak from an industrial power plant in the Pardubice agglomeration and the size of the area afflicted by the spread of gas during a terrorist attack on the Old Town Square in Prague were modeled. Since 1996, the Laboratory of Heat and Mass Transfer has also been located in Nový Knín. The mission of the laboratory is experimental investigation of heat and mass transfer, fluid dynamics, fluidics, and microfluidics. It focuses on passive and active control of flow and temperature fields on the intensification of heat and mass transfer in forced convection. The results of this research can be applied, for example, in cooling electronic elements using pulsating air flows. Several results from the laboratory in Nový Knín have been published in the most distinguished scientific journals, receiving international recognition and patents in Taiwan and the United States.